All right, we'll start this video with question 9. And question 9 is just asking about some facts regarding when x equal a is a 0 of a polynomial function. You can find those answers in your note sheets. Let's go to problem number 10, where we're working with the leading coefficient test to describe the left hand and right hand behavior of the graph of that polynomial. Well, remember, it has to always be in descending powers, and they don't have this one in descending powers, so I'm going to write that as 1/4 x to the 5th minus x to the 4th plus 9. And remember, you determine your leading behavior by the leading term. And since the exponent is odd, then the ends are going to behave like x cubed, and x cubed looks like this. Since the number in front of the x to the 5th is positive, I don't need to flip it, so the left is going to go down and the right is going to go up. So what does it do on the left? It falls to the left, and what does it do to the right? It rises to the right. So I would check those two parts. We're asked the same thing on question number 11. Describe the left and right hand behavior. It's not in descending powers, so if I rewrite it in descending powers, I'm going to base my end behavior off of this leading term. Well, since the exponent is even, the ends are going to behave like x squared. But since the coefficient in front is negative, it's going to behave like a flipped over x squared. So the left end goes down, the right end goes down as well. So it falls to the right and it falls to the left. Okay, so let's find the zeros of this polynomial function. And remember, the way we find zeros or x-intercepts is we just set it equal to 0 and solve it. This one's going to involve some factoring. And what I notice is, there's an x that's common. It's the first thing I always look for. So if I take the x out, I have an x to the 4th plus x squared minus 30. So there is the factoring of this polynomial. Now let's go further. The x to the 4th plus x squared minus 30 will factor into an x squared and an x squared. And to get a 30, I can go 6 times 5. And to get a positive 1, I'd go positive 6 and negative 5. Once you have it factored, you're going to set all your factors to 0. X equals 0, x squared plus 6 equals 0, x squared minus 5 equals 0. Remember, the degree of 5 tells me I'm looking for 5 zeros. Well, here's one of them right there. 2 will come from this quadratic, 2 will come from that quadratic. Well, let's finish solving these. Yeah, I got a little bit of room here. Let's take the 6 over and solve this for x. So I'll have x squared equal negative 6. Square rooting both sides, I have an issue. Those are not real numbers. That will end up being imaginary, and we don't want the imaginary ones because we're asked for the real zeros. So he's out, so let's work on this guy. Let's take the 5 over. Let's square root both sides. Don't forget the plus or minus, and I'm okay here because it's a positive square root of 5. Now look at how we want to list those. It says, enter your answers as a comma-separated list. Okay, so I'll type in the 0, comma, I'll type in square root of 5, comma, I'll type in a negative square root of 5. Okay, so those are all the real zeros I was able to find. The multiplicity of each 0. Well, what we see here is that x doesn't have an exponent on it. That 0 only occurs once. The plus or minus square root of 5, each of those are occurring once only. So I'm not really sure. Determine whether the multiplicity is even or odd. Smallest x value. I guess the smallest one would be the negative square root of 5. and his multiplicity would be odd. The largest x value would be the positive square root of 5. His multiplicity is odd. Actually, all of them, their multiplicity is odd. So we would answer odd in all those cases. We didn't discuss much about this, but when they're asked for turning points, the maximum number of turning points is given by the degree minus 1. So in this case, the degree is 5, and if I subtract 1, the maximum number of turning points would be 4. So that's how you would find that out. And then finally, you can use your graphing utility to graph that function. So let me go to my calculator and let's look at the graph. Looks something like that. I might want to bring my window in a little bit above and below, make it bigger so I can see those turning points. So I'll make that negative 20. And I will make this one positive 20. Just expanding that x-axis. See if that's going to give me a better view. Yeah, I can see a little bit better now. It's going to help me pick my choice. So it is looking like this one. Let me look a little bit more carefully at it to make sure. Yeah, that's our square roots of 5. Let me look back at what we had. Yeah, that would be our choice. Okay, so look at how we went about this. Finding the zeros by setting it equal to 0 and factoring. With our factoring, we find that we get a 0 of 0. These two are imaginary. These are plus or minus the square root of 5. They all occur once, so their multiplicity is odd. To determine the turning points, we take the degree, which is 5, and subtract 1 from it, and that gives us 4. That's the maximum number of turning points. And then we can use our calculator to verify our graph. I think we're doing the same thing on this one. So you work on that one while I work on it. Put it in your calculator, do some graphing, whatever, do some factoring, and we'll come back. Okay, so in looking at this problem, I'm going to do some factoring of the 3t squared minus 10t plus 7. When I factor them, I get 3t minus 7 times t minus 1. When I set those to 0, I get a 7/3 from this factor. I get t equal to 1 from this factor. And notice that in front there was a t squared. If I set t squared equal to 0, I just get t equals 0. But because that guy had a square on him, this guy occurs twice. So that particular 0 has multiplicity of 2. He occurs twice. Each of these occur once. And again, it occurs twice because of that degree. And also, let's look back at the top. How many zeros were we looking for to begin with? It's hard to tell because this one's in factored form. But if I multiply this thing out, the highest power would be a 4, a t squared times a t squared. That means I'm looking for 4 zeros. And I have this one, and this one that occurs twice, so that's a total of 4. So I would enter my zeros as a 0, a 7/3, and a 1 separated by commas. The smallest 0 is 0, and its multiplicity is even. The largest 0 is 7/3, and his multiplicity is 1, so he's odd. The 1, which is my 0, has multiplicity of 1. He only occurs once, and he's odd as well. Remember, when the multiplicity is even, your graph bounces on the x-axis. When the multiplicity is odd, your graph is going to cross the x-axis. Okay, the number of turning points is always the degree. In this case, the highest degree would be 4. 4 minus 1, which would be 3. And if we put this in our calculator to get a graph, under y equals, press graph, and we see this graph, which is the same as this image right here. Okay, so for problem number 14, all we want to do is graph it and match the graph on our calculator with one of the graphs that's given here. So calculator, type it under y equals, make sure I got it typed in correctly, check out the graph, and let's see which one matches with that. Looks like it would be this one, but let me go take one more look. That's at 5. So 1, 2, 3, 4, 5. Yes, we see that little dip there. So there's our graph. So calculator only. Let's see what's here. Oh, similar to what we did before. So you work on it. I'm going to work on it. Pause the video, do some factoring, find the solutions, and then come back and we'll see how it goes. Okay, so let's take a look at this one. X to the 4th minus x cubed minus 30x squared. Degree is 4, so we're looking for 4 zeros. If I factor out an x squared, I get x squared minus x minus 30. The x squared minus x minus 30 factors into x minus 6, x plus 5. So I get a 0 of 0 from the x squared. But he's going to have multiplicity of 2 because of the square. I'll have a 0 of 6 from x minus 6. It has multiplicity of 1. And remember, that's just because the degree there on these exponents. The exponents on those factors are just 1. Okay, for x plus 5, we'll get a 0 of negative 5. So we're going to list those separated by commas. The smallest x value of negative 5 has a multiplicity of 1, so he's odd. The largest x value of 6 has multiplicity of 1, odd. And the middle value, 0, has multiplicity of 2, so we would say it's even. And then finally, the turning points would be the degree, which in this case is 4, minus 1, which would be 3. That gives us our turning points. And now we want to graph it. So I would go to my calculator, type it in, look at the graph, and notice that it's crossing 1, 2, 3, 4, 5. It's crossing at a positive 6, 1, 2, 3, 4, 5, and a negative 5. Positive 6 and a negative 5. Let's check this out. Positive 6 and a negative 5. That's in contention. That one won't work. This one doesn't have the right W shape. So positive 6, negative 5, that will be the graph. For this problem, I would go to my calculator to look at the graph, but knowing my information about the leading coefficient test, since that degree is odd, it's going to behave like x cubed, where the left goes down, the right goes up, and since it's a 5 in front, that's positive, I don't have to reverse it. So on the left-hand side, it is, oh wait, hold on. Function rises to the left, nope, nope. Falls to the left, rises to the right. That's the one I want. Okay, so now I would go to my calculator, type him in, graph him, and also go to the table to get the values it's asking for. Notice from the table we get the 3 zeros, one at 0, one at 1, one at 2. So 0, 1, and 2 are my zeros. 0, 1, 2. Now, let's fill in those values. So from the table, I filled in the values for 0, 1, 1.5, and so on. Got those straight from the table on my calculator. Then from my graph on my calculator, I can see what it looks like here, and now I'm going to pick the graph, the matching graph on my sheet. This option would be the final graph for that function. This will stop this session.